Now, next topic of discussion is energy density, and if we define this, then we can say this is the energy stored in the material per unit volume. So that is energy density. And in electrostatics, we came to know that energy can be written as energy was equal to the half volume integral of d dot E, that is half volume integral of electric flux density with the dot product of electric field intensity. This is the energy in electrostatics we have seen there. And if we simplify this, then we can say it is half volume integral, this is epsilon E dot E dV, and from here we can write half epsilon E square dV volume integral, or we can say half d square by epsilon volume integral dV. Okay, so in continuation, if we define the density, then we can say half d square by epsilon, magnitude of it, d square by epsilon, it will be the energy density, okay, per unit volume. So it is the energy density. It is in electric field, that is half epsilon E square. This is the energy density in electric field. Similarly, in magnetic field, if we try to find the energy density, then we can say energy in magnetic field, energy in magnetic field can be written as similar to this as it is written here, volume integral of magnetic flux density, as it was electric flux density, here it is magnetic flux density with the dot product of magnetic field intensity, here it was electric field intensity. Similar to that, we can find the energy in the case of magnetic field, and if we simplify similar to that, then we can say it can be written as half volume integral, B can be written as permeability times intensity dot product with H volume integral. After simplification, we can have volume integral permeability times intensity square dV, okay, and in another form it can be written as half volume integral B square divided by permeability, and if we can write in form of density, this is just energy. If we try to find the energy density, then we can have half B square by permeability or half permeability times H square. So in this way we can find the energy density in case of magnetic field as it is in electric field. So from here it can be seen that the electric as well as magnetic field can be used for storing energy. In electric field, the capacitors are used to store energy. Similarly, in magnetic field, the inductors are used in magnetic field to store the energy. Now let us discuss Faraday's law. Basically, it relates how does the magnetic field can induce an EMF or an electric field in any material. We have seen that electric field were originating from charges and magnetic field were originating from currents. Now we will see the relationship between these two quantities. Faraday's law states that static magnetic field does not induce any EMF or electric field, but a time varying that can be or dynamic magnetic field is responsible for inducing an electric field. So from there we can say the time varying field can be dependent on time. This is responsible for producing or responsible for electric field, is responsible for E. Okay, so if it is varying, then A will be produced, and that E will relate with this relationship. E will be equal to the rate of change of flux. This is magnetic flux. Magnetic flux. This magnetic flux can be written as, for n number of turns, it can be written as n phi b, and phi b is the flux due to one turn, and phi b can be written as flux density times area. So from here what we can say, either area should vary or flux density should vary. So there should be relative variation between these two. From here we find that the variation in phi b is necessary. Okay, so from here we can say the necessary condition are conditions to induce the EMF, because EMF is related to electric field. Are, the first is the relative variation should be there. Okay, so variation should be in space as well as in time. And second thing, the magnetic field is required. It is important to be there. Magnetic field is to be required there, and the variation between field and A should be required. Either area is changing or B is changing. And third thing that is important, set of conductors are required. Set of conductors. So these three conditions should meet, then we can say EMF can be produced, and that is the relate with the magnetic field. So these three are the necessary condition for EMF to induce in magnetic field. Okay, now according to this Faraday law, we can say Faraday law, according to this, EMF can be equal to the rate of change of phi b here, and if we assume n is equal to 1 for single coil, single conductor, then it will be equal to the EMF will be equal to the rate of change of magnetic flux. And Lenz modified the Faraday's law by adding the negative sign in induced EMF. He said that induced EMF Okay, let us show it by V. It is equal to the minus d over dt, we can say phi b. Why negative? Because of effect opposes the cause according to Lenz law. That is, the cause is time varying magnetic flux and the effect is induced EMF. So induced EMF will opposes the variation of the flux. If flux is decreasing, then EMF will be induced in such a manner that it produces the current that tends to increase the flux. Similarly, if flux is increasing, then EMF will induce the current to decrease the flux. Okay, so in this way, he explained the placement of the negative side. That is how the effect opposes the cause. And from here, we can write n d phi over dt. Assume n is equal to 1 again. Then we can say d phi over dt, that is V. And this V can be equal to the E dot dl. We have studied this. And that is it can be equal to further minus d phi over dt. Now, flux can be written as surface integral of b dot ds. We can write like that. And if we convert line integral to surface integral from here, applying the Stokes theorem, then for this we can write the surface integral, the curl del cross E dot ds, to transform it into from line integral to surface integral. It can be written as minus, take it inside, surface integral, we can write b dot ds. Okay, so from here we can write, if we relate both are surface integral, so we can from here we can write del cross E can be written as rate of change of magnetic flux density. Okay, this is one important relationship. This is the differential form of Faraday's law. And as we can see, curl of E is non-zero. It means the field that is E is non-conservative and it is rotational. So from here we can write the one sentence we can write related to this: curl of E is non-zero, and it means E is non-conservative and it is rotational due to non-conservative nature. So from this relationship we can relate this. Okay, this is complete Faraday's and Lenz law. This is Lenz law. According to Lenz law, and according to him, the statement was the cause, the effect opposes the cause. Opposes the cause, and we have explained it how effect opposes the cause. There will be certain cases where EMF will be induced The first one is the transformer EMF, where we apply a time varying magnetic field. That is, the time variation magnetic field is possible by applying time varying source, and we will see how EMF will be induced. And the second case of EMF induced is motional EMF, that is due to the movement of the loop with some velocity in magnetic field. So both of them we will see one by one. So let us start from transformer EMF. Now let us see how the Faraday's law is applied in the case of the transformer. These are two windings of the transformer. Here varying source is given. N1, N2 are their windings, number of turns, and this is time varying voltage source, that is we can say Vm sine omega t. It is time varying. So in this case we will see how the Faraday's law is helpful to find the transformer principle. So from here we can say V is equal to Vm sine omega t, as it can be written from here, and corresponding Im can be written as, it is inductive, so we can say Vm by frequency times the inductance sine omega t minus 90 degree, as it is considered as pure inductive. Current is lagging by 90 degree. So this is the magnetizing current, we can say only if it is open. And from here the flux that is here can be written as maximum value of the flux with cos omega t, cos from here. So this flux links in the both the windings. So if this is the flux due to this current in this, then this flux will link to the secondary of the transformer as well. So the EMF that will be induced in this, we can say that EMF will be V2, and we know that is the EMF induced can be written like this, and this can be further written. Okay, from according to the Lenz law we can say negative should be there. Faraday's and Lenz law, negative should be there, and it can be written as minus. If we differentiate it, this value will be out, and differentiation of cos will be minus sign, so it should be phi m minus sine omega t, and as we are differentiating with respect to time, so omega further will be out like that. So if we will simplify, then this minus and this minus will be plus phi m sine omega t. This will be EMF induced in the secondary winding of the transformer. Similarly, we can write V1 in the primary winding of the transformer in the same fashion. Phi m omega is written sine omega t, and if we have equation 1, equation 2, then just divide 2 by 1. From here we can say V1 divided by V2 can be written as N1 by N2. Remaining terms will be cancelled out. This is the basic principle of the transformer. Okay. Transformer. So that is based on the Faraday's law. Now in continuation of the Faraday's law, we will see when a loop is moving in magnetic field, then how EMF will be induced in that, and what will be experienced to that. So let us consider a magnetic field B that is inside the plane, and the object is moving towards the right, and the force at the charge that is placed in the loop will be experienced, and that can be written as Q U cross B. We have seen this, that the force is IL cross B. From there IL can be written like this and cross B. And in this case, if the field is inside and the moment is here in right direction, then according to that the force will be in this direction for positive charge, and in this direction should be there for negative charge. And as the positive charge experiences force towards up, and it will experience force towards in this direction, the positive charge will accumulate here and the negative charge will starts accumulating here. And if positive charge and negative charge will accumulate in this fashion, then an electric field will be created that will be from positive to negative. Now, as we know, positive charge experiences force in direction of field. So due to this field, this charge will experience the force towards this, and negative charge will experience force opposite to the direction of the field. So it will experience a force opposite to this. So this is the Lenz law, that effect accumulation of here opposes the cause, that is field. So from here it verified that induced EMF is the effect that is opposing the cause, that is the magnetic field. We have studied that the net force at any loop in electrostatic is 0. Though there was torque, but the net force was 0. We have studied in previous lectures. So from there we can say the Q E plus U cross B. This is the net force. It is equal to 0. From here we can write E is equal to minus U cross B. And if we'll take line integral of this, then we can write E dot dl, line integral. Similarly, E dot dl can be written here as well if we are doing here. Then E dot dl will be equal to U cross B dot dl. Just we are adding the dot dl in both the sides. And if line integral can be transformed into surface integral, then we can write del cross E dot ds. This is the transformation we have done many times and we know this. This is surface integral. It will be equal to the minus del cross U cross B. Okay, this is surface integral, and dot ds we can write like this. So from here one identity we can find: the curl of E will be equal to the minus del cross U cross B. It is called the motional EMF because this is the EMF induced in the conductor by virtue of its motion inside the magnetic field. And from here we can write the total EMF will be equal to the transformer EMF plus motional EMF. and the total EMF will be equal to the transformer EMF when it is moving, then that will be the transformer EMF plus motional EMF. So it can be written as transformer EMF is nothing, magnetic flux density plus motional EMF plus minus, so it should be minus, motional EMF will be U cross B. So this is the total EMF. This is the total EMF, that is curl of electric field in any material is the total EMF, that is the combination of the transformer EMF and motional EMF. So these all are about the Faraday's law.